Before fire existed, your ancestors spent 5 hours every day chewing. Their jaws possessed massive muscle attachments. Because raw plant cellulose and tough animal sinew demanded relentless mechanical grinding before your species ever discovered a flame, raw eating dominated survival. Nothing on their plate was soft. How did your early body extract enough energy from raw dirt and raw flesh to build a massive human brain? Transport your mind back 2 million years to the sun-baked savannas of East Africa. Early hominins walked upright across open grasslands. These early human ancestors possessed oversized molar teeth capped with extraordinarily thick protective enamel. Raw wild plants contain dense, rigid cell walls. Without thermal heat to break down complex starches, your ancestors relied entirely on brute jaw force. Anatomists refer to this massive dental expansion as megadontia. Megadontia is the evolutionary enlargement of molar and premolar teeth specifically adapted for crushing tough, unheated food. Some early species even developed a sagittal crest. A sagittal crest is a sharp ridge of bone running along the top of the skull that anchors powerful jaw muscles. Their heads functioned as living mechanical nutcrackers. Did these massive jaws mean your ancestors spent all day crunching hard wooden shells? Scientists reconstruct this prehistoric menu by reading the microscopic signatures left directly on fossilized teeth. At the University of Arkansas, dental anthropologist Peter Unger analyzes fossilized hominin enamel using dental microwear analysis. Dental microwear analysis is a process that scans microscopes and scratches etched into fossil teeth during a creature's final weeks of life. Hard seeds create deep circular pits. Tough leaves leave long parallel scratches. Unger discovered that early hominins, like Paranthropus boisei, did not actually spend their lives cracking hard nuts, as researchers long assumed. Instead, their teeth showed microscopic striations characteristic of soft, tough vegetation. They chewed immense quantities of raw grasses, sedges, and fibrous marsh roots. Could raw leaves alone yield enough metabolic fuel to support a growing hominin body? Raw plant material yields surprisingly few usable calories in a raw digestive system. Your modern stomach would struggle to extract vital nutrients from unheated wild tubers. Raw starch granules remain tightly locked inside tough cell walls that pass through the primate digestive tract largely unabsorbed. To survive dry seasons, your ancestors desperately needed a denser source of raw calories. Raw meat entered the early human diet long before anyone ever struck a spark. Your ancestors were not dominant apex predators yet. They operated as opportunistic scavengers, watching saber-toothed cats and giant hyenas abandon fresh kill sites under the midday sun. Raw animal flesh provided dense protein and essential fats. At Olduvai Gorge in Tanzania, archaeologists uncovered 2-million-year-old animal limb bones bearing unmistakable marks of early human activity. The bones feature precise tool-cut marks positioned directly over percussion fractures. These butchery marks prove your ancestors used Olduvai stone tools to strip raw muscle from scavenged carcasses. Olduvai stone tools are simple river cobbles struck together to produce razor-sharp stone flakes for slicing raw meat. Why would early hominins take massive risks to consume raw animal flesh covered in savanna dirt? Raw flesh provided a concentrated packet of nutrients without requiring hours of plant fermentation. Yet raw muscle tissue presented a severe mechanical obstacle for early primate teeth. Uncooked animal muscle is elastic, slippery, and rubbery, making raw fiber difficult to tear. Human teeth lack specialized sharp shearing crests. Your ancestors solved this physical limitation by using stone flakes as external teeth to slice raw muscle. By tenderizing raw flesh with stone hammers, they bypassed hours of oral grinding. Plant foods still formed the foundation of their daily survival during long periods between meat scavenges. Archaeobotanist Amanda Henry uncovered direct physical evidence of these ancient plant meals by examining fossilized dental calculus. Dental calculus is hardened, mineralized tooth plaque that preserves microscopic food particles for millions of years. Inside this ancient fossilized plaque, Henry identified undamaged phytoliths. Phytoliths are microscopic glass-like silica structures formed inside plant cells that remain preserved indefinitely. Her analysis demonstrated that your ancestors regularly consumed raw wild barley, palm seeds, and underground plant stems long before agriculture existed. They dug these raw tubers directly out of the soil. They ate roots coated in raw dirt and grit. How did early hominins process these tough, underground plant organs when preferred foods disappeared? During times of drought, your ancestors relied heavily on fallback foods. Fallback foods are low-quality, highly fibrous roots or tough seeds eaten exclusively when preferred fruits and soft vegetation become scarce. Chewing these gritty fallback foods wore down their tooth enamel rapidly. Yet even a diet combining raw plants and raw muscle meat could not explain the explosive growth of the human brain. Here lies the counterintuitive twist that fundamentally recontextualizes human history. Raw muscle meat was not the primary superfood that built the human brain before cooking. It was raw bone marrow and scavenged organ fat. Apex predators like lions consumed soft flesh, but their jaws could not crack open thick antelope leg bones. Your ancestors used heavy stone cobbles to smash open those intact marrow cavities. Raw bone marrow consists of nearly 90% pure fat. Fat provided a massive, concentrated surge of metabolic energy that required virtually zero chewing effort. It was the cleanest raw fuel available on the African continent. This energy-rich raw diet triggered a radical biological transformation inside your own anatomy. Paleoanthropologist Leslie Aiello proposed the expensive tissue hypothesis to explain this evolutionary leap. The expensive tissue hypothesis is the biological principle stating that your evolutionary ancestors shrunk their digestive guts to supply energy for their expanding brains. Both brain tissue and gut tissue demand enormous amounts of baseline metabolic energy to maintain. A large, complex digestive gut is essential for fermenting massive volumes of raw, fibrous plant material over many hours. When your ancestors shifted to energy-dense raw marrow and organ fats, their long, heavy intestinal tracts began to shrink over generations. The metabolic energy saved from digesting less raw plant fiber was immediately funneled toward brain growth. Anatomists call this brain expansion encephalization. Encephalization is the evolutionary increase in brain size relative to overall body weight. Your body literally sacrificed its digestive gut to build your brain. Yet eating raw scavenged meat created an invisible, deadly hazard. Uncooked animal carcasses left out under the tropical sun rapidly cultivate dangerous bacterial colonies. How did your ancestors eat raw scavenged meat without dying from fatal bacterial infections? Your body still carries the chemical biological shield forged during that raw era. Human stomach acid is exceptionally strong. Your stomach maintains a resting pH between 1.5 and 2.0, matching the stomach chemistry of obligate scavengers like vultures and hyenas. This intense acid environment destroyed ingested pathogens before dangerous bacteria could colonize the intestines. Your ancestors survived raw scavenging because their stomach acid acted as an internal sterilizer. Despite these incredible adaptations, raw food placed a strict evolutionary ceiling on human development. Chewing uncooked food required immense physical energy and endless hours of daylight. Chimpanzees today still spend up to 6 hours every day simply chewing raw leaves and raw flesh. Because raw digestion is inefficient, early hominins could not push their brain size past a rigid limit. They remained trapped in a daily cycle of endless mechanical chewing. Raw calories were simply too difficult to unlock. The eventual invention of cooking shattered that evolutionary barrier forever. Archaeological sites like Wonderwork Cave in South Africa reveal early evidence of fire interaction. Controlled fire functioned as an artificial external stomach that thermal heat used to break down starches and denature proteins. Cooking increased net energy extraction from food by up to 50%. As cooked meals became standard, human jaws shrunk, tooth enamel thinned, and facial skeletons flattened over evolutionary time. Your modern wisdom teeth become painfully impacted today because your shortened jaw no longer possesses room for the massive teeth of your raw eating past. Look at your own body today. Your small jaw, your shortened digestive tract, and your hyperacidic stomach are living proof of a raw past that shaped your species. You carry the stomach of a scavenger and the teeth of a fire maker. Every meal you eat today rests upon millions of years of mechanical chewing in the raw dust. Before fire existed, your ancestors chewed raw earth for 5 hours so your brain could build the fire.